Welcome back for episode 2 of OMG OMICS, Bruker's new podcast series. Stay tuned to hear how Ramon Sun from the University of Florida makes science work for you. Our topic this month is spatial omics, and our guest is Ramon Sun. He's early career, but has already established an impressive record in the field of spatial omics, while dabbling in other areas of research as well. Ramon, thank you so much for being here.
It's a pleasure, Kate. Thanks for inviting me.
Now, you're not a formal mass spectrometrist by training, but we have you here on our Bruker OMG OMICS podcast series because you've entered this field in your career, and as you've progressed, you've started asking different kinds of questions that need different tools. Can you tell us about your academic path so far and how you landed at the University of Florida?
Yeah, of course. So I've been traveling all over the globe, really. So I'm Chinese. I grew up in New Zealand. I did my PhD in Australia, and then realized that all the best science is happening in the United States. So I came all the way over here to Stanford to do my first postdoc. And my wife got into med school at the University of Kentucky. So I kind of just dropped everything and moved to Kentucky with her. And finally got my first faculty position at University of Kentucky. And then she's coming to the end of her residency, and she really wanted to be somewhere by the ocean and place that's more fun for the kids. And I agreed. So there was an opportunity that I get to move to the University of Florida with some really, really close friends and collaborators who I've been working with for a long time. And, I fully realized those things are hard to come by these days in science. So it just felt like everything fell into the right place: family, collaborators, science, and resources. So that's kind of how I ended up in Florida. One of the main reasons we moved to the University of Florida is because they would buy us 2 of the Bruker's timsTOF flex instruments so I can do more imaging. That's actually one of the main drivers of me. One of the main considerations of how many of the flex machine I get to have.
It's also just nice to hear in your personal story that there's a consideration for family, for balancing. It's always wonderful to hear that you have a 2 scientist-oriented household. I think those types of personalities sometimes come together. Do you have anything else you might want to say on that, since we're recording on Valentine's Day?
Oh yeah, no. See, my wife is actually sleeping downstairs in the bedroom. So she's still in residency, and she's had a tough couple years. We have a 3-year-old. One at a time, COVID hit, and she's pretty much just stuck in the ER. So she's an emergency medicine resident. So she pretty much just stuck in the ER. We barely get to spend any time together, and it's tough on her to not spend time with kids, and the work-life balance is so much harder for a resident compared to me, which is a scientist. So I have a lot of freedom in terms of what I do with my time. So the work and life balance is really just taking care of our kids and hoping to keep my lab and career going, but also really to support my wife, who's working much harder than I am on a daily basis, and actually saving lives every single day. So it's definitely a weird path in the last couple years, but I think everything's worked out really well. We have a healthy, fun, kind 3-year-old, and she's about to finish residency, and it looks like I have an amazing bunch of people in my lab that continuously helping me to build my career and theirs as well. So it's an interesting path. I guess everybody's a little different on their scientific career, but also I'm very much into supporting my spouse and in terms of she getting what she wanted out of her career too, not just trying to just only focus on mine.
So when I visited you recently in your lab, going through and talking about your philosophy for raising students, for lack of a better term, for mentoring them and getting them to a good scientific place, I can see how that interplay exists. Can you tell me a little bit about, how you impart your awe of science to your students?
Yeah, sure. So I come from four generations of educators. So my dad and my grandparents and my great granddad, they're all university like lecturers and professors, not in science. My great granddad is actually a really famous philosopher and ancient writing expert. So he was kind of famous back in China. So yeah, so I mean, education kind of runs in the family, but I kind of did not really very much enjoying classroom setting teaching. I much rather mentoring on a one-on-one basis with my trainees, such as my postdoc and my graduate students. And I guess I think I'm like, relatively new to this academic research setting and being a mentor for everyone around me. So I do think that the way I think is a little different as a newer. Like I don't push my trainees towards academic research. I just want them to have a goal and work hard for it. I'm constantly telling them they can be successful no matter what they do. Either in industry, academia, being a teacher, all of those. Whatever they choose to do, all I'm asking them is to work hard for it, right? Work hard for their goals. So at least people in my lab are very goal oriented for their own career successes. Like I constantly talk to them about what they want to do when they finish their PhD or they finish their postdoc, and I help design scientific experiments and hypotheses and projects based on their goal and what I can train to benefit them in their future careers. And in terms of the science, I think obviously I get excited over everything. I have a scattered mind, but I think I talk to my trainees almost every day, right? Like I'll explain why I'm excited about certain data or why I want to do some of the projects, and I really do think they can sense it in my tone and in the way I act. Like when I'm excited, when I'm genuinely excited and wanting to help, say UN sarcoma is one of the projects. Like I'm genuinely wanting to help these kids to live, to see college, to get married, to have kids, and a lot of them don't get that opportunity anymore. And I can sense that at least as long as I'm genuine, I'm really trying to help these trainees really, appreciate that, and I really uh, adapt to it as well, and they become really, really invested and excited about what we do at the same time. Um, so most of the academic research, I always associate a human physiology and human disease aspect of everything that we do, right? So for every technique they do, every experiment they do, I explain to them, look, this is what we need to do, and this is who we need to help, right? So this is the connection. We may not see our progress in the next 10 to 20 years, but I promise you, the stuff that you do is going to make a difference one day, even if we just save one person or 10 kids. It doesn't matter. And a lot of them really, you know, grew to like that scenario, right? So they really also share my passion now, and the curiosity for science.
Well, I think that the trail that you've blazed thus far speaks to your passion for this because you formed multiple companies. You've been able to create assays and scientific methodologies that are useful in certain disease areas. Could you tell us a little bit about some of that?
Yeah, sure. So again, since the very beginning, I'm a little bit scattered minded, and I find lots of different things interesting. It's especially when I was a graduate student and when I was a postdoc. So before I had Cooper, research sometimes just isn't enough for me to keep engaged. I am engaged in research, but when I get home, I can never just be that person that kick my shoes off and watch TV. I always have to be doing something, right? I'd be working out, running, or starting companies. So obviously, had some stupid and terrible ideas and lost some money, but eventually we kind of got there, right? So but what kept me going in science? So I did a longer than normal postdoc, and I did two postdocs. It's 8 years, and everybody out there knows that postdoc is not a something that pays the bills, right? And in my mind, a lot of the postdocs actually ended up switching jobs because the prosperity of earning six figures very, immediately, rather than sticking it out to see what you can do as a PI. So very early on, I realized that fact, and I've told myself that if the only way I can be fully committed to science, academic research, and helping people in the long run is for myself to be financially independent of my job. So that's kind of my first goal. I realized that. So it's like, so from that point on, I've always invested in science. I've put every heart and soul and sweat and blood into all my experiments. But also I realized that, look, I need to be able to take care of my family. I need to be able to not worry about the financial aspect, so I can fully commit on the scientific aspect. So that's where I started looking at companies and coming out with ideas. So we randomly came up with the idea of not science related, just have a random app out there back in when I was in a postdoc in Stanford. Continued working on it. I was up late at night because people in India I don't know how to code and write an app myself. So I was giving the ideas to them, and I was up at 12 o'clock in the morning communicating with people who are doing it online to finish writing the app, and I ended up selling it. I wouldn't be saying like I'm insanely rich from selling the company, but it's enough for me to help my wife go through med school, keep a decent living standard, a lifestyle, but also it really, really helped me to focus on science now. So now with my son is here, I don't do any of I have companies and I've continuous put disclosures, but I would say 95% of my effort is all just in the lab and in science. Um, the new assays that we're developing, I think is super cool, and I think it's going to make a difference in the clinics with your Bruker's instrument actually. But that is actually part of the lab workflow now. It is no longer something that I do on the side. So like if anything that I'm helping, it's like, okay, so I'm combining my passion and helping people. And if this thing can be commercialized into a a clinical diagnostic assay, all the best at the same time, right? It's like a win-win-win situation for everyone.
Fantastic. I just love it. I love hearing every time you talk. There's always such passion, and there's always a connection and an intention there that doesn't necessarily come through for a lot of people. So I really
Oh,
appreciate you
thank you.
sharing. Yeah.
No, happy to. Yeah.
All right. So why don't we turn back to the science for a minute? So I appreciate you sharing, more about your life and how you got to this point. But I'm sure you've also noticed and experienced that spatial biology is just having such a huge moment right now. So what are your thoughts as this starts to propel forward? And does mass spectrometry have a significant place here?
Yeah, no, of course. So obviously I'm biased because I am invested my the future of my research program in spatial biology, and especially spatial metabolomics, right? So I don't know if you guys saw the latest Nature article that just came out last week that highlight the 7 technologies to watch, and spatial metabolomics, especially multi-based spatial metabolomics, is right up there with the space telescope to watch for 2023. So it's not just, I guess it's not just us who thinks that this is the technology of the future. It is the technology of the future, and I think Bruker's is always leading the way at innovating on the technology front. That makes all of our researchers' jobs so much easier in terms of utilizing the tool and get stuff done, right? So you guys pretty much made the best tools out there so that we can apply our like creativity and see how to use this to get the most out of our research. So yeah, I think we're going to see a lot more spatial metabolomics papers. We're going to see a lot more applications of spatial metabolomics in actually answering foundational biological questions, right? So I don't know. There's a new paper that came out in Science Advances that they use spatial metabolomics to figure out a new type of muscle fiber. That was a very fascinating read. I apologize, I cannot remember the senior author's name, but yeah, that was an incredible story to read and think about how you can apply this technology in actual research now. So I think we're going to see a lot more things that we don't even know that we wanted to know from 5 to 10 years ago. So it's definitely an exciting space. And then I do think that mass spec is this last frontier in the spatial biology revolution, I think, because you have genes that translate to protein. And what does protein do? Protein carry out metabolic function that form metabolites, whether it's oxphos, yeah, I know, yeah, I hate the word, whether it's ATP, whether it's lipids, whether it's aniline glycans, heparan sulfate glycans. All of these are products of protein activity, enzyme activity. So you go down the line of transcription, translation, and now we're at the metabolism front of this. And then the key is having good computational methodologies to actually help us make sense of all the data, really, from that perspective.
So that's the other side where I see the innovation that comes in with you. I know that you take out a lot of the data that you collect, and then you take it out and do the computational work that you want on it, and then bring it back into Skills Lab, which is our main
Yeah.
software. So, what do you need and what do you see for the future of AI and for bringing in new technologies and tools to help researchers get the output that they need to make decisions on biological questions?
Yeah, well, that's a very good question, and then I think I guess there's no one answer to that question. I think it's really up to the creativity of the user, right? I think that the Bruker software and the API, we're only limited by our imagination from that perspective, right? So anything that you can think of, we should be using and applying using these extremely beautiful and complex data sets. So at least from my perspective, I'm working with Dr. Derek Allison from University of Kentucky. Again, I make a lot of good friends when I collaborate with people, and we end up being really good friends in the long run as well. So I'm still working with a lot of good clinicians back in the University of Kentucky who have been working with the last 5 years. So our goal is to apply AI, well, more specifically machine learning, to really help pathologists to predict digital pathology regions using the skill and the spatial metabolomics hardware. So our goal is really boost pathologists workflow, right? If they're limited at 10, 20 slides a day, we hope to use machine learning AI to tell them where to look and maybe hopefully bring them that up to 100 slides a day. So with that, they can, one, much faster at finding pathology regions that they're interested in, and two, I would definitely envision that the turnaround back to patient is a lot faster. So another good friend's dad recently was diagnosed with a rare form of cancer, and the pathology turnaround is very slow, right? They not no jab on the pathologist for sure. I mean, but it's harder to understand these kind of diagnoses. So when you have cancer, the last thing you want to do is sit there for 3 to 5 days and getting a report back. So one of the efforts that we do with AI and machine learning is to speed up that process in the clinics in the future, right? But that's not a 5 year. That's not something that can be done in 5 years or maybe 10, but it's not. It's certainly not going to stop us from trying, right? We're going to take one step at a time and get there when we get there. So there's a lot of time ahead, right? But I think the potential is here, the technology is here to be translated to the clinics now, and I really think there's lots of potential in that area. And then on the research side, what we do is really rely on anatomical annotation matching to high dimensionality reduction mechanisms. And actually, we just started to implement the multiplex IHC mass spec workflow to give us more cell lineage identity in term and make more sense of what we're seeing in the spatial biology platform. So there's definitely a lot more future there. We're still actually applying the technology and see what we get, just because I guess no one's done it, right? When it comes to spatial metabolomics, the hardest part is you go out and you search for a paper and say, hey, has anyone done this better, or have I already have a path forward? And then you look Google and you're really like, oh, I'm on my own on this one. So we almost just kind of have to take it day by day and look at our data and see what we can get out of it on a day-to-day basis right now.
You're building your own OMG moments because you're like, oh, I have nothing to reference. I have nowhere to go with this.
Yeah, exactly. And it is actually really fun. So my computational science PhD student, she amazing student. And I think we're getting ready to prepare some manuscripts and using some of the new code that he developed to look at all the different anatomical regions and put the metabolism into metabolic pathways and all in one RStudio code that everyone can use and hopefully apply it to the Bruker workflow. And the goal of that is really to help scientists who use the spatial metabolomics technology to make more sense of their data from like a 10,000 foot view, right? Rather than going through one image at a time, we really want to hey, look, in the frontal cortex in the brain region in AD mice or AD humans, it looks like glycol or phospholipids is decreased or increased in certain regions, and then give them a path forward to test their hypothesis in additional biological models.
So, Ramon, I'm going to come back to the theme of curiosity because you brought it up a few times, and it's something that's always resonated with me. There's a quote from Einstein about staying curious. And so I'm curious, do you have any big brain people that you really admire and that have helped you influence you in how you think about and look at science?
That's a great question. I guess all the scientists who done it better and who done it already before me, all of those people are inspiring. Like I don't really have a single person. I'm more of like I'll look at everybody's qualities and I'll try to learn as much qualities from everyone that come before me and see what makes them successful and kind of just incorporate all of that to myself, right? And I am curious, and that's one of the, I guess, qualities that makes me continue want to do these scientific investigations. But I also think that curious is not enough in my mind. I think you need to be fierce and willing to take risks in this constantly evolving scientific world. Having curiosity, I'm curious about this, but if I don't know how to do an assay, if it prevents me from doing it, which I think I ran into a lot of these cases as I was being a scientist in a career. It's like having a curious mind, but don't have the tenacity or be fierce to actually accomplish your curiosity, to really see what's down the other end. That seems to be a barrier for a lot of the scientists, or at least some of my trainees that I've seen out there. And that's another the thing that I've always tell my trainees is like, hey, let's not worry about finances. Let's not worry about is it too expensive. We have one shot at this. We're either gonna succeed and help people, or we're gonna go down in flames. But what I'm certainly not going to do is try to save my research dollars and drag out another 5 years and doing mediocre science that only what is safe to do. So I think having a curious mind is great, but you got to be fierce and be willing to apply and do things that's out of your comfort zone to tackle that curiosity. That's in my mind. And actually, buying a spatial imaging instrument when I have zero mass spec experience is one of those things that I did to sacrifice my curious mind, right? So Richard Drake did a pilot experiment with me that we've been collaborating since our first email exchange, right? He's kind enough to just do a set for me. our paper got accepted in the Cell Metabolism a year later, and now we have a joint MPI R1 together on mapping brain glycans. After seeing that very first data set, I was just, lack of better word, mesmerized by what Spatial can do. And I remember my mentor at the time said, "Hey, Ramon, you only get one ask when you start your tenure track position. Are you sure a spatial mass spec imager, mass spectrometer is what you want? Because it's going to take up over 50% of your startup, and there's real no guarantee that it will work, right? This is 5 years ago. There's no guarantee that it will work." And I just told him, "Look, this is something I want to do." The curiosity sets in, but also I'm like, whatever, if I go down in flames. But if I'm successful, I can be really successful with the spatial technology. So kind of just went with my gut feeling and purchased the machine and start using it.
So it sounds like no regrets.
No regrets here so far. No regrets. Zero regrets. And scientifically and family, it's kind of I don't have a lot of regrets.
That's awesome.
Yeah.
So I know that you cited that Nature article, and I'm really glad that you brought that up with the technologies to watch this year. But what else do you have your eye on that might be complementary to spatial metabolomics? Do you see something else that you think you're going to start incorporating in to help balance your analytical techniques?
Yeah. So one of the other aspect that we're really investing is in vivo OMICS imaging by MRI. So I have a graduate student starting to look at metabolic changes in the brain. This Matt Merritt, who's literally, if I'm at work, he literally sits behind me. He's this amazing guy, super smart. He came from UT Southwestern, and he does metabolism, so we speak the same language. But he's a NMR, in vivo NMR and MRI expert, and I really want put myself in one of those MRI machines and start measuring my brain metabolism, right? So he's got this contrast agent using deuterated glucose, and we're just gonna put this magnet on my head and start measuring. And I think whatever we see using multi-imaging needs to be implemented in the clinics, because we always see endpoint metabolism differences, but we need to be able to figure out how we can help these with patients who's living. And I think MR or in vivo NMR is technology to pair with multi-imaging to really bring this into a more physiological setting. So that's kind of the pairing technology I am invested in with multi-imaging. I want to use contrast agents, isotopic tracers. We have two of the. I don't know if you know that Florida hosts one half of the National Magnet Labs, so we have incredible resources in our couple Bruker NMR systems down there too. So they have incredible NMR MRI. We have two 3 Tesla human MRI instruments. Really would take advantage of translating my knowledge from multi-imaging or multi-spatial data sets to come out with hypothesis and tests in humans, right? And I told Matt Merritt, it was like, the moment that machine's up and running, I'm the first one that's gonna go in there to get scanned. So and now there's targets, right? So we've done enough upfront research. Now we can find we have candidate to pursue in the MRI to study dementia, cancer, and we can, once we have these targets, we can go to the MRI and start looking for them to start coming out with, rather than don't know where we're looking for in an NMR MRI scan. Now we have these unique targets. We can use tracers and contrasting agents to really hone in on how are these changes during AD or cancer, and how we can either use them as diagnostic clinical biomarkers for progression, or find ways to reverse these phenotypes.
It's just astounding, the connections that you're making and the various ways that you're able to see, be curious, be fierce, and enact all of this. I think you've got a really special place in Florida, and they're helping you to continue to grow and do amazing things.
Yeah, 100% agree. And I really just want to highlight the fact that it's not just me. One, my lab, I really shouldn't be me. It always should be we, because I have an amazing group of trainees, research analysts, scientists in my lab who's absolutely who build this absolutely amazing culture that everyone, I hope everyone's happy. But they all work hard, they push each other, they help each other, but also every bit of academic success for myself, or if any, it's I've got to credit to my collaborators. I'm just one person. I don't have the knowledge in the world of multidisciplinary everything that I want to study, right? So, Matt Gentry, Craig Vanderkooy, Derek Allison, Matt Merritt. These are just few of the and Warren Allen. And some of these collaborators I met in Kentucky. Some of them I met in Florida. We became great friends. But not only that, but also they held my hands through things that I don't understand. They help to satisfy my curiosity needs. Right? They have their own areas of expertise. They can help apply all of those things to what I do, and vice versa. So it's really a mutually beneficial relationship. But almost everything that I do, I do rely on collaborations. I do rely on friends, and I guess I just couldn't credit myself. Like, I think if anything, my team and my collaborators deserve more credit at willing to work with me and put out with me on a day-to-day basis.
Well, I've actually got a challenge for you to kind of finish this off, something that you might have to turn back to your team for, because I noticed a small deficiency when I was in your lab. There's no mascot, Ramon.
Yeah.
You don't have a champion to channel all of that curious, fierce energy. So I don't know if you can think of something right now, but you might have to go back to that collaborative team.
I might have to that collaborator team, and I'll have to get back to you on that. I am always the techniques keeps me going. The science is the end product, but I'm always in love with developing new tools to study something that I need to understand. And to be honest, that's a big part of the reason I stayed in science, is the developing new tools. And I'm one of my Nick Dinkel, my postdoc mentor, saying if you can't do it without, if you can only do science with pre-purchased kits, you're not a real scientist. And I've got that resonated with me really well since I started, right? So I've always loved developing my own complex or simple techniques to answer complex biological questions. And that's that part, not all of it, but that specific part of science is what keeps me curious and keeps me going, and just so passionate about it. But again, using Bruker's instrument and developing new techniques is some of the coolest things that we've done in the last year or so.
It's been such a pleasure to get to know you over the course of the last year. We've interacted in a variety of places. You've welcomed me into your lab. I'm sure we'll continue to work with and interact with each other. And I can't thank you enough for sharing.
Oh, no problem. Come back to the lab anytime. All my people love you, so come back and visit anytime.
Happy to be welcomed with open
I don't know what you bribed them with, but they all love you. So.
I hope you enjoyed the second podcast that we had with Ramon Sun from the University of Florida. I'm really kind of in awe, and I'm having my own OMG moment at how well he incorporates so many different aspects of science to bring together a way to answer his biological questions. But we did see a small challenge that he has. He doesn't have a mascot in his lab, and I'm sure his students, his trainees, his postdocs are in need of something to keep them going more than Ramon. So I'd like you to look at what's flashing on the screen and vote for your favorite in the comments section.